built on ModelFusion. Storyteller is an app where you can essentially generate an audio story for a preschool kid. So so that involves a lot of techniques. You can essentially like talk to it and say, hey, like give me a story about like a boy playing in the woods, and it would then go on and do everything, right? Generate like take your speech, turn it into like text, generate a story, generate images that are consistent, generate the full narration script, different voices, and rate it all in different voices at the same time. So that's pretty cool that that all works, but there are a few challenges. So the challenges are to make it really consistent. You can see a few examples. So the images need to be consistent, the titles need to be consistent, and so forth with the story for overall, like, so it makes sense. But then also there's a huge UX problem, because if you generate this with AI end to end, it probably takes like 2-3 minutes to generate. And like if you have the user waiting in your app with a loading screen for 2-3 minutes, like 99% of the users will be gone by the time the story is ready. So there are like a variety of techniques that I'll go into to bring the first thing way faster. It's still like 10 to 20 seconds until it actually starts playing the audio, but that's a lot better than 3 minutes. And you can actually show parts way earlier, like after a couple of seconds, essentially. All right, so here would be the example. So I'm like a little bit scared to try this now, but I will. If there's echo, then let's see. Actually, play this. Maybe I'll play it on here.
Fritz, why did the trees look so sad? And why are you all so quiet today? Benny,
There are different voices generated, the story is generated. I should go to the next slide. Okay, and then the images come and so forth, right? Uses a bunch of different providers. So for like text generation, embeddings or transcriptions, this is using OpenAI. For speech synthesis, I'm actually using 2 providers. I'm using Element, and I'm grateful to them because they gave me a bunch of free credits. And like with this, you really go through your word counts really quick on the speech providers. I also used 11 Labs for some of the other voices. And finally, for images, I use Stability. So architecture-wise, I designed a small client server separation framework here with like we essentially specify 3 different things. You specify a client schema, a not schema, that tells you, hey, those are the inputs. All this is fully type safe, and those are the events. So this actually sends back a bunch of events to server send events. You have some client code where you handle the different events that the server sends, and then down here you have the actual generative AI flow that runs on the server. All the generative AI stuff usually requires server, even if you do phones, because you don't want to leak your keys for OpenAI. So, so the flow would be essentially like you do invoke flow, which is something specific that I'll show you later, and then this does a post request and creates this custom flow. The custom flow then creates a separate server send event source that is sent to the client receives the events through that. For larger assets, it becomes a little bit tricky, and when you have multimodal stuff, you generate images, you generate audio, those are larger binary assets. So here, like, it doesn't make sense to like send them through the server send events. Instead, those assets get stored. I can imagine I'm storing them to S3 or somewhere else. Right now, I'm storing them on the file system. You send back an event with the actual URL, and then it gets retrieved like any other image or audio file. And finally, when you deal with AI, logging is super important. You want to log like all your prompt inputs, prompt outputs to actually be able to improve the system. Something very different from like regular software engineering, where it's easy to test and write unit tests. Here it becomes much harder. You want to log and observe and then do evaluation. Okay, how does this look like on a high level in real code? First, there's the schema. So this is a schema that essentially defines, hey, those are the inputs that are going to be sent from the client to the server to start the whole thing, and then these are the events that are being sent back. Client is React right now, but essentially what I wrote here with the invoke flow would work in any other framework or no framework at all. So when you stop recording on the client, so you stop recording your audio, this invoke flow is called. You give it a base URL, you give it the schema and the input, right, from the client, and then you define how you really want to handle all the events. We update your UI accordingly. Again, this is pretty important because the overall flow of those is pretty long, right? When people talk about like service and events, service and rendering and streaming, it's usually the matter of seconds. Here we're talking like minutes, right? So it's a little bit longer on. On the server, I wrote a Fastify plugin that you can set up with some file system message storage and file system logger here in this example, but theoretically you could log it anywhere you want, like to some bucket or something, or some logging provider, and the assets you could also store anywhere you want. And then you just register your flow. Which brings me to the main piece, which is the flow. That's actually a very simple thing. It gets the inputs, and then it's a long-running async function that can send events and store assets and so forth. And the rest gets handled by the plugins, everything gets sent to the client. And this is the rough idea of the overall architecture. And now I'm going to go through the actual flow, which is the interesting piece, right? This is where the magic happens. So here on the top, you see how the UI looks originally. You start recording the topic, and say something, right? It shows you it's recording. Once the audio recording is done, it's being sent to the server, right? And the client switches to a loading speed. Then the first AI call happens. You need to transcribe the topic. So here I'm using Whisper, just a call to Whisper. And what you see here, this code is ModelFusion. So I have a little abstraction with the various providers. You can do things like generate transcription, generate JSON, generate text, speech, and whatnot, right? And then you give it the data. So this is a pretty simple one because Whisper, you can just throw it the data. And then after 1.5 seconds, you get the transcription back. Send that to the client. It's a little bit hard to see here, but the first loading state changes into whatever you set. Right? And this is after 1.5 seconds, the user sees, okay, something is happening, this is not broken. The next thing is to generate the story outline. And I guess the trick here, so this is to generate text, and I call it an OpenAI model. The big thing here is that I call GPT-3.5 Turbo Instruct, which is a very specific model. So I'm not sure how familiar all you are with LLMs and AI techniques. Maybe raise your hand if you've worked with AI stuff before, right? A couple of people. The models have vastly different speeds. So if you take GPT-4, this will take 20 times longer to do, right? So I specifically picked a model here that I know is very fast, and in fact, like GPT-3.5 Turbo Instruct, they said it's the same speed as Turbo, but I found it to be 4 times faster. So this gives you kind of like the story outline after 4 seconds, right? So we're now talking like about 5 seconds. And then, because the point of creating the story first is to keep everything consistent, right? If I don't create the story first, immediately create the title and so forth, everything is inconsistent. So now I have the story, and in parallel, I can create the title, I can create the image, I can create the narration.
Lars, we need to change the battery for the streaming. Mm-hmm. So can we do like a little break? Yeah. And I don't know if you have any questions. You can ask them now while we are changing the battery for the streaming. Any questions in what you've learned so far? Try.
How do you check the quality of the output? You said you would log everything.
Well,
the microphone is not going to work.
Right now for this one, it's mostly eyeballing.
So that's why.
Stories and like,
so
I
just
think
think
a lot
of
people start out
the
like
microphone
eyeballing it and seeing if
just
it's
change the
decent.
battery.
But then when you like say you have a real application that you want systematically improve, this is where logging comes in, right? And then you can like either do that manually, but you can set up like fancy evaluations. And there are many different approaches, including like having LLMs rated or other stuff.
I definitely had a blast and would recommend coming to this event the next time it's on. I'm not sure when they'll be on next, but it is a really good event to meet people who are...
Number 9 of 20, whose phone's gonna ring? Oh, yes, we've got a person, we got a winner, let's give them a round of applause.
with some accent. But now most of you think you're from Greece, so I don't have to pretend that I have an accent. I can speak Greek English. Okay. And now we can continue to
The system, the barrier control. So it's quite a complex system.
It's really cool. Like I learned a lot from them. I also learned a lot.
Okay? And now, clap your hands.
Thank you.
Yeah, no problem. The story is generated and then a few things are being kicked off in parallel. The first one is simple title generation. So again, using GPT-3.5 Turbo Instruct, I feed it the story. Here I do a little bit of prompt engineering where I say, okay, stop on a quote sign because I started with a quote sign, make it a little bit more constrained and efficient. But essentially I feed it the story and say generated title. Takes not even a second, so this is a pretty fast one because the result is pretty short. And then an event with the title gets set to the client you already see after like say, 6-7 seconds, hey, this is the title, and the user continuously sees something is going on. Okay, in parallel, the prompt is being worked out for the actual image generation, right? So that's a two-step thing. First, we need a prompt, and then we need to generate the image. So here I'm using a slower model, GPT-4, because I experimented with a few models, seeing like how good the prompts are, what result I can get, and I found like, hey, here I do need GPT-4. More experimentation or fine-tuning may give you a different model. And essentially take the story again for consistency, put it here and say, hey, generate me a short image prompt with like some additional instructions, should have a few keywords and so forth. GPT-4 is a little bit slower, so we have 4 seconds here. But then we need another step. We need to generate the actual image. So take this prompt that got generated, the image prompt, add a little bit around it for like, hey, have a nice colorful illustration for preschoolers, and I feed that into stability, right? To generate the images that you actually see. And the images that you get out are often like looking pretty decent for the title, and I was quite happy with them. And this takes a while. This takes 15 seconds, right? So overall, like until like the image shows up, it's probably 25 seconds. You can't just send the image to an event stream. It's just not a good practice, too big. So what I do here is I store the image, and then I send the path with the URL, and the client retrieves the image and displays it like any other image, right? And then the last and the biggest piece is actually generating the full audio story. So complicated prompt, again, GPT-4, but there are a few important things going on here. First of all, like this is a function call. I give it a full-blown Zod schema that gets transferred into a JSON schema. So like GPT-4 knows the structure that I'm expecting. So this gives me structured output back. Complicated prompt, I'm not going into it too much, but it essentially says, hey, this story needs to become an audio story. Here, like different roles, you need to specify the roles and so forth, right? The crucial thing is I stream it. I stream JSON, and that may sound weird. So the way this works is OpenAI essentially sends back text, right? And it's always partial JSON. So if you JSON parse it, it won't work until the end. So I partially complete it, pass the partial JSON, and give you the partial JSON. And then depending on your app and your schema, you know kind of like how to parse it and what to do with it, right? In this case, if it's not complete, I know it's like a parsed object. I know it's a deep partial of the overall structure I expect, so I can actually type parse it. And then I take just the array elements that are completed, and even for the first part, can immediately start like doing the next steps while the streaming is ongoing. And that's the core idea here, to deliver the actual like audio as quickly as possible, right? So we stream the whole story. And then at the end, it's like, obviously the last one is fully typed and everything. So yeah, So once we get one of those fragments, a little bit more needs to happen. We need to figure out what voice to give it, right? Either we have a voice already or we need to determine the voice. So let's say like we don't have a voice. Well, what happens then is we want to give it fitting voices. So how do we do that? Well, first of all, obviously differentiate female and male, so we match those voices, but then you like sometimes want to give it a softer voice, sometimes a harsher voice, and so forth, right? So we generate a voice description for that character for the story. So essentially like a prompt that gives it the story, says, hey, here's the schema that we expect from the output. Please generate a fitting voice for that character and what they are going to say. Right? And then we use embeddings, which I'll explain a little bit. You may have seen that for retrieval augmented generation. So you take text and you put it into an embedding space, and then you can later on search similar text, and you essentially get a semantic search. And I use that here for voices. So what I do is like I had all the 11 Labs voices and all the element voices, and I had voice descriptions, and I embedded those into the embedding space. And now I get a voice description here, and I search nearest neighbors in the embedding space to get like voices that are kind of semantically similar to the voice description back, and then I'm going to use those voices. And this essentially is the vector store in the back, and I do a retrieval with a certain similarity threshold, a few results, and then I check, hey, are the results there or not? Like, have I used this voice already? If I've already used it, don't use it, but yeah, it works out pretty well. So after the voice, the last piece is then to synthesize. So here's like a few providers, and it's actually one of the things that I like about ModelFusion is that because it's all the same interface for the different providers, right? You can easily integrate multiple providers. You don't have to change the code as much. And in the case of text-to-speech, you can actually use like several providers in the same manner and in the same app. So yeah, that synthesizes the speech with the content for the voice, creates an audio file, sends an event with the audio file, retrieves the audio, and then it starts playing, right? And this cuts this whole process down by several minutes. And then while you're listening, obviously in the back, everything gets generated. But at that point, we have time, right? Yeah, and this is the whole flow of like progressively like including that information. Cool. And I think with that, I'm at the end of my talk. I hope you enjoyed it. Everything I showed you is open source. So as Storyteller, you can check out. The full code is online, and the same for the ModelFusion framework. So yeah, thank you.
Thank you very much, Lars. We're just going to have to take like 2 minutes to set up the next speaker.